Okay, in this video I'm going to talk about the circumcenter of a triangle. So basically we have a triangle denoted ABC, and we consider the perpendicular bisectors of all three sides of this triangle. So like this is a right angle from the midpoint of the side. This is a right angle from the midpoint of the side, and this is a right angle from the midpoint of the side. And so the theorem says basically that all three of these perpendicular bisectors intersect at a single point, and this point is the circumcenter, which means the center of the circumcircle. So I will draw it like this. So the perpendicular bisectors of the sides of a triangle, of any triangle, intersect at a single point, and this point is the circumcenter of this triangle. Okay, so let's prove this. So there is a property of the of a perpendicular bisector of any segment, that it is the locus of the points that have the same distance to the to the ends of this segment. So these two distances are always the same. So this is, let's say, if it's segment AB, so then the perpendicular bisector is the locus of points x such that AX is equal to XB. So in particular, if we apply this to our case, so let's for a while let's remove the third okay, so I will draw another picture. So we have a triangle ABC, and we consider for now we consider only two perpendicular bisectors. So from the side AB and from the side BC. So and we denote this intersection point by X. So we don't yet know if this X belongs to the third perpendicular bisector, but like we need to prove it. So from the property of the perpendicular bisectors that I mentioned, we have that, so since X belongs to the perpendicular bisector of AB, so X belongs to the perpendicular bisector of AB, it follows that XA is equal to XB, right? Because it belongs to the perpendicular bisector of BC, it follows that XB is equal to XC. So we consider this segments. So from the first, because it belongs to the perpendicular bisector of AB, we conclude that these two segments are equal. And from the second, because it belongs to the perpendicular of bisector of BC, we conclude that these two segments are equal to each other. So therefore, all three of them are equal. So therefore, XA is equal to XB, which is equal to XC. In particular, we get that XA is equal to XC. So XA is equal to XC. This by the property of the perpendicular bisector, this implies that X belongs to the perpendicular bisector of CA. And this means that all three, this means that, so X belongs to all three of them, and so this is a common point of all three perpendicular bisectors. So all three perpendicular bisectors intersect at a single point. So now, why is this point the circumcenter? Well, by definition, because we just proved that this point X is has the same distance from all three vertices of the triangle, right? So XA is equal to XB is equal to XC. But so from this, by definition, X belongs to the, not X, excuse me, but A, B, and C. So A, B, and C lie, well, I can write it, so they lie on a circle the circle with center X and radius this distance x, well, if we denote, let's say if we denote this distance by r, which is xa equal to xb equal to xc, so then A, B, and C lie on the circle with the center x and radius r. So by definition, it is the point at the same distance from all three vertices of the triangle. So this is, and this is, and this is the circumcircle of the triangle ABC. So this concludes the proof.